Most repeated PYQ of D block elements from this topic. Hello students, let us start. Key points about potassium dichromate. K₂Cr₂O₇ split like K plus Cr₂O₄ minus 2, which is dichromate. Dichromate structure, if you see here, 3 oxygen atoms here, right side 3 oxygen atoms, middle there is CrO-Cr bond, that bridge bond CrO-Cr. All these 6 bonds, 1, 2, 3, left side 3 bond, right side 3 bonds, 6 bonds are of equal length due to resonance. But these 2 bonds, which are labeled as A and B, no resonance, and these 2 bonds are of different bond length. But remember, A and B bond length greater than remaining 6 bonds. Because remaining 6 bonds, double bond converted into single bond converted to double bond due to resonance. We know these 6 undergoes resonance, but here no resonance. So bond length of A and B greater than remaining 6 bonds. Preparation of K₂Cr₂O₄ from chromite ore or ferrochrome, chrome iron, FeCr₂O4 formula occurs in 3 steps. Step number 1, chromite ore react with NaOH to form yellow colored sodium chromate, brown colored Fe2O3. In place of NaOH, you can use even Na2CO3. Products are same, but here you will get CO2. It is soluble, it is insoluble. Okay. Second step, sodium chromate, whatever we got here, carry forward it, react with H2SO4 to form sodium dichromate Na2SO4 H2O. Sodium dichromate react with KCl to form K₂Cr₂O₄, which is orange colored compound. So finally we got potassium dichromate by using 3 steps. Properties of K₂Cr₂O₄. Action of heat. When potassium dichromate heated, it gives yellow colored potassium chromate, green colored Cr₂O3. Colors important. Cr₂O₄, when placed into basic medium, it gives CrO4. When CrO4 placed into acidic medium, it gives Cr₂O₄. So what we can specify here, Cr₂O₄ stable in acidic medium, whereas CrO4 stable in basic medium. Why? Because whenever if we place potassium dichromate into basic medium, it is giving CrO4 minus 2. So stable in basic medium. Next, dichromate ion, when allowed to react with cold H2SO4, it gives CrO3, which is red in color. Hot H2SO4, it gives Cr2SO4 thrice, which is green in color. K₂Cr₂O₄ is strong oxidizing agent. Undergoes reduction. If it is undergoing reduction, it forms Cr plus 3. Cr plus 3, so for example, I minus converted into I2. Cr₂O₄ minus 2 acting as oxidizing agent, and oxidizing I minus into I2. One more reference reaction here. Ammonium dichromate on heating gives green color Cr₂O3, colorless gas. Gas, when allowed to react with magnesium, it forms Mg3N2. Allowed to react with water, MgOH twice, and ammonia gas. Ammonia gas goes in contact with HCl, it forms ammonium chloride, white dense fumes. Previous class JEE advanced question. 5th point. Ruby is red and emerald is green due to Cr plus 3 ion, fact based information. Cr plus 3 responsible for both red color as well as green color of ruby and emerald. Next, potassium dichromate react with H2SO4, H2O2, hydrogen peroxide, forms one blue colored compound which is CrO5, which also represented like this, which is having butterfly structure CrO5, 2 peroxide linkages available here. So each oxygen minus 1 here, so we can call it as chromium diperoxide. Blue color fades due to decomposition of CrO5 into Cr plus 3 and O2. So blue color fades due to decomposition of CrO5 into Cr plus 3 and O2. The most repeated PYQ, what we specified just beginning of the video, that is based on chromyl chloride test. Very important. Used to identify Cl minus. Potassium dichromate react with NaCl in presence of H2SO4 forms chromyl chloride, KHSO4, NaHSO4. Chromyl chloride vapors, reddish brown vapors. Chromyl chloride vapors, when it allowed to react with NaOH, it forms yellow colored Na2Cr₄O4. See under note, CrO4, which is chromate, dichromate, chromyl chloride. So chromate ion, dichromate, chromyl chloride. Everywhere chromium is in +6 state. Everywhere. D3s, D3s, D3s. Hybridization. Paramagnetic, diamagnetic, diamagnetic. Paramagnetic, diamagnetic, and diamagnetic. Tetrahedral, tetrahedral, tetrahedral. yellow colored compound, orange colored compound, reddish brown compound. Okay. Now, AGBR used in black and white photography, like hydroquinol used in developer solutions. See, black and white photography during development of reels. Hydroquinol used as developer solution during development of reels. AGBR react with hydroquinol so that AGBR convert into AG and forms another compound. So here hydroquinol is developer solution. Just you have to remember developer solution used in development of reels. Hypo is used as fixer solution to remove AGBR present on black and white reels. Black and white reels, photographic reels coated with AGBR. Excess AGBR removed by using hypo solution. During development of reels only, it is overall process. Fixer solution is hypo, developer solution is hydroquinol. AGBR react with hypo, it forms one soluble complex AgS2O3 twice minus 3. Iron, platinum, tungsten, tantalum will not form alloy with mercury because of less affinity towards mercury. Hg plus exists like dimer like this, which is diamagnetic in nature. Hg plus 2 undergoes disproportionation to form Hg liquid with Hg plus 2. Disproportionation meaning same element undergoes oxidation reduction and form different oxidation states. Comproportionation is reversible reaction. Different oxidation states of same element convert into same oxidation state. Comproportionation is reverse of disproportionation reaction. Hg2Cl2, which is commonly known as calomel, we know in electrochemistry you studied, reacting with KOH to form red colored HgO, HCl, H2O, Hg. Copper sulfate 5H2O, blue vitriol formula CuSO4 5H2O. Structure you see here, 4 H2O molecules forming coordinate bond with copper, 1 H2O outside this sphere, this H2O, it is between sulfate as well as copper sulfate. So forming hydrogen bond, dotted lines are hydrogen bonds with coordination sphere as well as sulfate ion. Hydrogen bonds are here 4. Let us see JEE Mains 2026, 23rd January shift 2 question. 23rd January shift 2 question here. Oxidation state of chromium in final product formed in the reaction between Ki and acidified potassium dichromate solution is. See the here. In this reaction, what you will get? Potassium dichromate, above also we studied same reaction. Here K₂Cr₂O₇, the solution if you see K₂Cr₂O₇ react with Ki. If it is reacting with Ki, here it forms Cr plus 3 and then I2. Right? Ki acidified. So here Cr plus 3 and I2 form. So answer according to the given question, answer should be plus 3. Answer is plus 3. So it is in plus 3 state, Cr plus 3. JEE Mains 2026, 21st January shift number 1. Most repeated question I said, right? So it's the first reaction. Again, chromyl chloride test. This year they asked, even last year also they asked. Okay. Observe now statements. NaCl plus K₂Cr₂O₇, H2SO4, and then it is giving in the product C, X is the number of O2 minus 2 units, Y is the total number of oxygen atoms present in, Z is the oxidation state of chromium. So question asked like this. So first of all, I am framing reactions here. Whatever we wrote above, I am writing those. See. First reaction, NaCl reacting with K₂Cr₂O₇ plus H2SO4. H2SO4 giving chromyl chloride plus and goes on KHSO4 if we complete it, and then H2O, one more, that is NaHSO4. Okay. So in the product C, X is the number of O2 minus 2 units, Y is the total number of oxygen atoms present, and Z is the oxidation state of chromium. Okay. Let us see now. And then second reaction, whatever they mention. So chromyl chloride CrO2Cl2, if it is reacting with NaOH. Second reaction, if it is reacting with NaOH, it forms sodium chromate. Same reactions already we studied above. Na2CrO4 plus NaCl plus H2O plus H2O. Okay. Next. First of all, here what is AB? You see here. It is A. What is B here? B is Na2CrO4. It is B. According to given question, if we write. And the third equation, H2SO4, H2O2. So now, in third equation, Na2CrO4 reacting with H2SO4 plus H2O2. Here it forms that blue color butterfly structure CrO5 plus Na2SO4 plus H2O. So these reactions we completed. Right, now what is C here? Now C is CrO5. This one is C. Question C now. See, CrO5 how you can write? CrO5 also you can write it as CrO and then O2. Peroxide ions they are asking. Peroxide ions we need to find. So X is equal to number of peroxide ions. So number of O2 minus 2 here, because 2 peroxide ions already above butterfly structure also we observed. Y is equal to total number of oxygen atoms. Total number of oxygen atoms how many? Here it is 5. Z is equal to oxidation state of chromium. See here, oxidation state of chromium, here already we wrote. See this one, plus 6. That's what they mentioned, CrO2 twice. So here, oxidation state of chromium is plus 6. So now overall value they are asking. So here x plus y plus z, 2 plus 5 plus 6 is equal to 13. So answer here it is 13. You can mark it as 13. Okay. I hope all the questions clear to everyone. For more updates, follow the channel. Thank you. Thank you everyone.